Hello everyone, my name is Anton, and I have been a long time fan of the Luxonis OAK series. I ordered the original OAK 1 soon after Kickstarter campaign started. So after that I ordered OAK Lite during its campaign, and I was among early beats, so it was pretty cheap for me. And I reviewed both of them on my channel. And because of this, when there was OAK D Pro release, Luxonis contacted me and asked if I can review this one, and I gladly accepted this because it also was a nice 3D camera. So when the OAK 4D generation was announced, I contacted Luxonis myself and asked for a review sample, and they kindly agreed. So, full disclosure, this particular unit was provided for me for free, but Luxonis didn't affect my video and my review is fully independent. But they answered a lot of my questions, and I hope that actually that made this video much better. In this video I will cover why this platform is important right now, my impression of usage of testing this, because I already tested this for maybe 2 months, basic overview of OAK, how it's performed, where its strong parts, where it's not still strong, and how to work with this platform. I will go through base pipeline, because it's a little bit more complex here than it previously was. I will cover why it's like this and so on. And of course I will highlight some limitation. So let's start from background. Why OAK cameras matter? My earliest experience with Luxonis hardware was 5 years ago. I think this one was in 2020 during COVID time. Usually I use them in some my hobby projects or for fast demo for some of our clients. For example, like if I need stereo camera, this one is pretty easy to connect, almost the same, and basically close to RealSense, but I like their software a little bit more. So if I need some quick demo with stereo, it's a good camera. Mostly I use its capabilities as stereo camera. I used NPU, like here is Myriad X, as you know, and I used it initially maybe first year, but then Myriad X was a little bit outdated. Yes, it was enough for some project, but mostly I just use this as a stereo camera. I have always liked the design and engineering quality of Luxonis cameras. They are from metal, pretty nice heat removal, pretty nice optic, and so on. A few of my clients also used OAK cameras in their prototypes or projects, and I consulted them along. Why not everyone is using them? In my opinion, there are a few main blockers for old cameras. OAK cameras were never standalone unit. You always need an external compute device like Raspberry Pi or Jetson or something, because here it's just camera plus NPU, but you need like externally process all this. USB connection, it's not the best connection as far as you know. Yes, it's became much better lately, but still maybe it's not what you want in the real production system. And of course, NPU right now here it's not the best. So if you run some complex neural network, you need to run them independently. And actually, this second issue with USB was addressed by Luxonis a few maybe a year ago or 2 years ago when they introduced this power over Ethernet cameras. And all other issues, actually they are resolved here. because it's standalone unit, and this NPU is much more capable than this Myriadic. Let's start speaking exactly from this Qualcomm NPU. If you compare this with previous generation, it's maybe 30 times more performant, because it was 1.3, 1.4 tops, and now it's 48. It was a little risky move for Luxonis, in my opinion, because when they started this development a few years ago, Qualcomm was not a solution that you wanted to provide to community, because Qualcomm software ecosystem has changed, but Qualcomm software ecosystem has changed dramatically this 1.5 year. A few years ago, to work with SNPE, Snapdragon Neural Processing Engine, you were required to become a partner. Now it's openly downloadable. Still, some problems are still present. You can check one of my previous video about Radxa Q6A about working with this Qualcomm infrastructure directly. Yes, right now Qualcomm become better and better each day because they acquired Edge Impulse to make this life easier to work with their stack. They acquired Arduino, which has a big open source community, and I think they hope that people will build something around them. What are the reasons for using Qualcomm right now? NPU is compatible with NVIDIA Jetson nano-level devices. A little bit worse in terms of pure performance, consuming less power, and in general these Qualcomm chips are cheaper. Also, Qualcomm hardware is also known for low latency image pipelines, and because of this easier to work with images directly, a lot of, for example, robotics companies right now, they are choosing Qualcomm as the main platform because for them it's a little bit easier to consume images. Qualcomm is a big and wasteful infrastructure system. A lot of framework, approaches, super interesting but pretty complex. Luxonis here did a pretty elegant move. They wrap all this Qualcomm complexity in their own framework. If you worked with previous cameras, it's basically the same framework. Yes, they updated it a little bit for easier of utilization, but basically you're using Luxonis Depth AI infrastructure instead of Qualcomm, and they are fully supported this Qualcomm neural networks inside. So basically some wrapper in their pipelines. A bit later I will go through all this inference pipelines, why it's good, why it's not excellent, but let's go. So we started with Qualcomm, but also I need to mention about 3D capabilities. You know, it's a stereo camera right now. Yes, they have some variant with mono, but let's speak about stereo because stereo cameras are always interesting. And I will just briefly touch all this 3D stuff in this video, and I will make another video in 1 week where I will discuss a little bit in more details, especially about a new Luxonis algorithm with stereo depth estimation with neural network. And it's pretty interesting algorithm, so let's return in 1 week in details. And now I just briefly show you like classic algorithms, is stereo depth estimation, and another one stereo depth estimation algorithm. From mechanical part, this camera is, as always, pretty nice, like metal box and nice cameras here. Also it has illumination for improving depth imaging, so great. Algorithmically, however, Luxonis for their main inference pipeline still relies largely on traditional block matching for depth estimation, the same as RealSense and the same as the most cameras on the market or back and so on. In modern AI workflow, the stereo depth can be improved a lot if you're using stereo depth estimation neural network. Luxonis good understanding this problem with the classic approach. So this is exactly why they did the new stereo depth estimation algorithm. And in my opinion, it's working quite good. So they, it's also possible to use few existing stereo depth estimation neural network, for example, a CREStereo net, but this specifically as CREStereo net, it's working like it's not the best stereo depth estimation network in comparison with foundation stereo. And I think it's partially maybe fall back on CPU because this inference time pretty slow, and I don't know. It's working. It's much better than any NPU device on the market which can run such neural network. But specifically Luxonis algorithm, in my opinion, it's already more stable and better. But again, in 1 week we will return and discuss this stuff. Let's speak about supported neural networks and Model Zoo, because this is like AI camera, everything in this box, and you should run your neural networks directly here. Luxon is providing their Model Zoo with a lot of models. Of course, it's classic object detection, classification neural networks, k-points and pose estimation, 3D detection and some regression models, and of course some depth estimation, as I already mentioned. There is a big variety of models. Yes, you have like both support of ultralytics models with all the complexity, but also you have a lot of nice open source models which you can freely use. They also have Whisper examples here, but I couldn't reproduce this example myself. Probably they will fix this in the next release. The main gap here remains in LLM and VLM models, which are essentially needed for robotics if you want to go into robotics with this camera. Of course, there is some model support here for transformers, for example, Whisper or image generation, but right now you just can't run out of the box some llama model here. The team here mentioned that they will support probably Moondream in one of the next releases. Also, they have good feeling about exporting here diffusion policy neural network, which is VLA network. So this platform is probably, it's just on the edge of using some big neural networks. I think it's mostly will depend on Qualcomm releases, because Qualcomm release in this, not the open source, but freely the libraries with a little bit gap about in comparison with what they have right now in their release. So this NPU theoretically is more possible to work with some networks, but at this time there is pretty big limitation here. But for regular AI, classical vision approaches, this NPU perform great. It supports all network. Also a little bit tip here, there is two Model Zoo, one from Luxonis and the second from Qualcomm. And Qualcomm, it's directly like from their engineers. You just need to choose correct platform, and then you can download this DLC file, which can be just inferred directly with Luxonis software. Let's go to software architecture and development workflow. And it's pretty interesting and tricky here. Luxonis has a unique approach to unify support across all the platforms, because they need to support this camera with MiriadX and this camera with Qualcomm. And already they have a big infrastructure, and they want their client to seamlessly migrate from old cameras to this new one. And it's a bit strange experience. It's working, but you need to like rotate your mind a little bit to work with this, because it's more stream-based approach. Oh, of course, it's like fully Python support. You can easily do, but you need to think in these diagrams with stream. You need to route them. It's not a complex task. You easily can do this. but you need like to change your to shift your impression here a little. There are at least 3 different ways to run neural networks on this platform and work with it. First, like if you want to develop directly on this platform inside, you can just SSH directly here. You need to install like Depth AI infrastructure. Just use these 2 commands. It's not obvious, but because they right now here it's running Yocto Linux, and it's a little bit hard to find all Python libraries here, but with this approach you easily can install a lot of them. It's the first approach. It's not the most convenient and it's not the main one, but maybe it's the most classical. So I start with this. The second approach, approach that Luxonis proposed for this camera. It's called OAK Agent. It's basically runs through Run-C, which is platform for Docker, Podman, and all other containerization infrastructure. And it's like OAK Agent, it's containerization from Luxonis. Because camera run Yocto based Linux system, it's hard to use this system like with all libraries. So basically they build in Debian container with all your program, all your dependency, and pushing this container with this OAK agent into the camera. It's nice in some senses, in some other senses I don't like this approach. Let's basically go through pluses and minuses. Plus, it will work guarantee. Plus, it will give you ability to easily deploy your solutions. And the minuses, of course, it's not super native when you want like to debug your code with your Python. It's a little bit more complex. I don't know if I couldn't like connect with my VS Studio directly to this container and connect to code running there. So debug probably is a little bit more complicated. And of course, there are a lot of different approaches to deploy your code on the edge. For example, in some project we used Balena. In some other projects there was some custom solutions. And if you already have some infrastructure, I am not sure that it will be easier to use this already existing infrastructure with this Luxonis camera. So probably you need to fine-tune something or switch on their approach. So it's first 2 approaches, and there are like two different, a little bit fork of this previous. So you can inference and run directly with Qualcomm libraries. It will be similar to video like I have with Radxa Dragon, but you need to install everything here and then you will have this ability. And the final, there is a Luxonis hub where you can connect this camera directly and then communicate with this camera through this hub. I personally didn't try this. I'm not super big fan of situation when I rule in my hardware through some third-party cloud, but I think for some people it may be the most reasonable solution because you just online can deploy all this container and easily like in no code regime work with this camera. So maybe for someone it's a great approach. Let's speak about expert. Usually it's one of the crucial problem how I can export my neural network, what are approaches and so on. And here basically you need to like the final export here will be through Qualcomm library. You have a lot of opportunities here to export your neural network. So the first one, it's the same Luxonis hub, but for this model export, I think it's pretty nice if you don't want to go deeper in all this complication. You just send your ONNX file in cloud, push the button export, and you have your DLC model. Great. I always like this simplicity if you don't want to go deeper and just want to play it out of the box. But of course, they provided a regular experience, so they have Docker, which allow you to export your models. You just give line of parameters, run them with this Docker, and you have your model out. Basically, in this Docker, they have this SNP tool, which wrapped around the request and a little bit infrastructure. But you easily can connect inside this Docker and use this tool directly. And in my opinion, it's maybe the most convenient way. So I tested all three of them working. And for easy models like detection, classification, everything working great. If you have a more complex model, you need to look more in their documentation. One of advantages that I mentioned, it's latency of Qualcomm platform. And it was really important for me to validate which latency this platform has right now. Right here, it's a little bit of a few layers of additional complexity. You don't have direct access to camera here. You need to work with this through this Depth AI. Actually, it's quite complex because you don't know how you can run glass-to-glass latency test here. Here, it's a little bit complex. I built a few pipelines, like with console streaming of times, and I get around 60 milliseconds of latency. I speak with Luxonis team, and they confirmed that yes, probably it's the best I can get from this camera. In my opinion, this result, it's not as great as I expected. Actually, it's not a worse result, because if you work with a lot of stereo cameras, for example, you will have like few hundred milliseconds latency. But for example, for direct streaming, if you will optimize your Jetson pipeline with some commercial library, for example, this one, you can get 25 milliseconds glass-to-glass latency. Here it's more. Maybe some different companies will optimize this pipeline as well. But right now, because you don't have this direct access, I don't know about how they realize this on the board, how they did all this connection, where the memory is going from, where the image going, in which memory. But right now it's acceptable for most application. It's okay, but it's I was hoping that it will give me a 10 millisecond latency and it solve and it will beat everyone. But no, it's like regular, but not the best. So let's shortly wrap up. This camera is the thing I hoped from Luxonis for a long time, and they actually released it, and it's quite good. It's maybe not as perfect as it theoretically could be, but it's like solving all issues that was in this ecosystem half of a year ago. And actually it's pretty out-of-the-box experience right now, which you can take, connect to your robot or existing system and have everything. I really hope that even in few months, with all these new releases they mentioned, it will be one of the best camera on the market. Speaking of price, it's also great, because if you just buy a Jetson with good 3D camera, it's cheaper than Jetson with 3D camera in such quality of box. So right now this solution is pretty unique. It's a powerful board which can infer everything, which has everything on the board, which with nice power over Ethernet connection, with nice dust and water protection, with super nice quality of construction, and pretty nice lenses. So right now this camera, in my opinion, it's unique camera on the market. It's definitely covering a lot of problems, but of course it has potential to grow even within such platform. I I'm hoping that they will go through this and will improve, because we need more cameras like this, and it's definitely. So thank you for watching. Again, subscribe on this channel, because I will have at least 2 videos about this camera. And if you want to know more, if you want to look at more samples, so join and we will explore it together on this channel. Thank you for watching. Bye.